Hi everybody and welcome. Today we're going to be talking about proportional reasoning word problems, and a lot of these problems will use scale factors. So your goal after watching today's video will be able to look at some proportional reasoning word problems and solve, and we'll also be able to recognize and apply scale factor to those questions as well. So starting off, a good example here. I know it's kind of hard to see, but that is a little miniature figurine right there of the Empire State Building, and in the background is actually the Empire State Building. So when I first taught this years back, gosh, I can't remember when, but I think it's my Texas students, I would always give the example when talking about things like scale factor and similar figures. I was like, well, if I have a little figurine of the Empire State Building, all of the proportions are the same. So if I, Ant-Man style and the Avengers, if I just blew it up really big, it'd have all the same dimensions and the same things as the Empire State Building itself. So I actually did go to New York City later on that year, and I had my wife take a picture of me holding a little Empire State Building figurine right in front of the actual Empire State Building itself, because it's the perfect example of what we're doing, of proportional reasoning and of scale factor. So, if the Empire State Building's somewhere around 1,000 or more feet tall, and the figurine that's in my hand is like an inch tall, we're obviously going to have a very large scale factor there somewhere, probably like a 5 to 10,000 range times larger than the figurine that's in my hand. But, if we had that special Marvel Ant-Man technology and we were able to, punch in how many times bigger that figurine needed to be, we could blow that up in our backyard and boom, the Empire State Building would be there. So cool example, and a related example, again, scale factor and proportional reasoning, just looking at something that has the same dimensions but is just smaller. So our definition for today is going to be useful for solving some of these word problems is scale factor. So this is just a ratio of corresponding lengths in similar figures. So I'm going to break out my amazing drawing abilities again. So maybe we have a miniature horse, and this may or may not be true, but if miniature horses are just shrunk versions, but proportionally the same as Clydesdales, we would see that, and again, autographs, I can sign those later if you need them for my beautiful artwork. Maybe it's like a 2-to-1 ratio. So maybe this Clydesdale is 2 times larger than that miniature horse, and we're going to see that that scale factor right there is 2-to-1. And that's going to help us go through and to solve questions like this. Sometimes if they give that to us as a statement or reasoning, we'll be able to set up questions a little bit easier. All right, so let's do a couple of questions here together, and then we'll be set up and be in good shape. So you can pump out 2 liters of blood for every 7 people. How much will you need, or how many people will you need? So we don't know people, so put an X there on the bottom. We need to get 12 liters of blood. Using that, we're just setting up that scale factor. So we need to have, 6 times more blood. So basically we're saying we need to have 6 times more people. So let's check, use our proportional reasoning with cross multiplication and see what we get. So we have 2 times X equals 12 times 7, or 2X equals 84. Divide both of these by 2. We'll get to X equals 41. Check that for reasonableness. Again, we said it should be about, we need about 6 times more blood. So we should see about 6 times more people needed. And again, I just made a mistake there. 84 divided by 2 is 42. So again, checking our work there with division. Again, apologies for that, thinking too quickly here. But that works. Okay, so we can see that they proportionally line up. It's about what we expected. And again, the reason why we set these up in these proportion equations is sometimes it's not as easy as just doing 6 times 7. Or sometimes we can't see that scale factor right away. Or even sometimes if we have multiple unknowns, we'll need to, again, have that algebraic equation set up. All right, let's do another example. So for every 3 papers that Mr. R grades, we're going to see that Mr. Hinkland grades 2. If we're grading together, and I grade 117, how many has Mr. Hinkland graded during that same time? So I'm a little bit faster than Mr. Hinkland. Math, maybe it takes a little bit less time than like reading a history essay. So let's see what we got. So we have 3 times X equals 117 times 2, or 3X equals 234. Divide both of these by 3, and we'll get that answer of 78. So we'll see proportionally, it's a little bit less than me, but, you know, reasonably close to being on track. So Mr. Hinklin would, in that case, grade 78 papers. So that's the idea going through these. And again, make sure we also have some units in the answers as well. I want to make sure we're not forgetting that. But that's the idea in terms of setting up, gosh, we're at the wrong unit there, setting up these proportions. We're thinking about scale factor. We're thinking of relating real-world things to each other in a constant proportional rate. And when we do that, we'll be able to set up these equations, and we'll be in good shape for solving. So thanks for tuning in, everybody.